Welcome back. We want to talk some last little bit about the idea of data normalization and how we can work with the idea of the third normal form, or 3NF. When we're working with our project, we had the idea of we had some tables working with customers, employees, orders, and products. And as we switched off and finished off the 2NF, we noticed there was a problem with one of the columns and working with a quantity idea. And we had that idea that we need to work together, we need to put together in order to satisfy that many-to-many relationship we see between the orders and products. One of the best things to do is often introduce a new table, a composite table that relates these many-to-many relationships and extracts that relationship out over here to a composite table based on the primary keys of that and any other extraneous information that we need to know to keep track of it. In this case, the quantity of each thing that we're ordering. And so that's where we have that order products table right here. Now when we look at this, we have the idea that we have a primary key. This has a composite primary key because it's made up of the keys from these two tables right here. So it gets a composite key, which are each also, of course, foreign keys because they refer back to this row over here in products and in orders. So we have that reference right there. On the orders table, we have order ID plus the customer ID that's attached, which is a foreign key. The employee ID for the employee that actually placed that order, also foreign key, and all the things that go inside the order itself. Same thing on products. We have the product ID and all the product information that attaches just to products. We go over here and we talk about employees. We have the employee primary key and all the detailed information that's directly linked to that. Same thing with customers with the priority with the primary key of customer ID and all the information about the customers in that table. And so when we're talking about that, when we talk about breaking the tables down, we go to the second normal form. We take all the dependencies out and we split them up based on the objects that relate to each other, the concepts or the tables that they were working with. And then we split them up into the tables that belong with that. And whether we hit it here immediately with the order products, we notice that many-to-many relationship. And it's not exactly great for putting a single thing because the problem with a many-to-many relationship is every order has some products, but it could have more different products, and so we have an idea that will violate that 1NF relationship because when we're talking about that many-to-many, we'd have, oh, this one has one of this and three of this and three of that. That would be commas that would be separating values inside the quantity field, and that doesn't make sense because we wouldn't know which quantity they go to, what about the order on that, all that fun stuff. Same thing with the actual products that are ordered on that, those would be separated by commas too, and that's not cool. And so in order to get past that so we can have a better table structure, again, we break that many-to-many relationship and we farm it out into a subtable right here of the order products, where that composite table information can be handled with that. And so that's what we have to make sure we take a look at doing. And so anytime you're working with that and we're looking at something that has multiple options for that, especially like with an orders products relationship, that's a great idea to have a composite table that breaks the many-to-many relationship. And now we have an order has at least one order product. We have products right here in that relationship right there. And so we can have that relationship broken from a direct relationship between them and have a composite table that then links them together with that. And we have a better way to express that data without violating the 1F atomicity that we would have to do if we try to keep all the products and orders together in orders as a single table, because we don't want to have that. Atomicity is way more important than having everything in a couple times. Atomicity of data is way more important than having smaller tables. Or less tables, because the number of tables we're working with, again, a table needs to reflect exactly what we're talking about. They should be just like we were talking about when you're dealing with objects and stuff in object-oriented programming. The idea of the table you're working with needs to hold the information it needs to hold and nothing extra. And that's explicitly what we're working with when we're talking about data normalization, is we're working with it and making that data happen. So again, once you've gone back, look at the corrected key for how you can work with and do that breakdown of the data so you can make sure you identify all the correct pieces, and notice what happens when you put together the idea of a relationship between the different components. Make sure you take a look at the relationships between the components so you can decide about how those things relate to each other, and you can have that appropriate relationship right here. Again, when you see that there's a relationship of information, that's usually where that foreign key comes into play, because an order has a customer who ordered it. So that links back over here on that foreign key relationship. Same thing on the employee who is tied to that order. That foreign key relationship goes back over there. And so that's how those tables relate to this table. The orders table relates to the order product, because that order ID links back to the order. Each product that it's in there also has that product right there, and the quantity of each product we're ordering for that order. And that's how we can build that structure up and work with that. And that's a common pattern you can look at when you're working with database analysis and how to actually design databases to work with real data. Thanks again, and have a great day. Cheers.